Okay, welcome to Let's Get to the Marks. Here we have a question about chlorine, so you need to know this stuff off by heart. It's part of your Group 7 content. I suggest most of this is not skill-based. A little bit of it is when we're forming the ionic equation, but stuff like just knowing these equations off by heart is purely down to your content. You need to get revision cards, you need to revise this, you need to be able to write these down off by heart. Okay, practice that when you're watching TV, when you're chilling out, but you should be able to write all of this stuff off by heart. All right, let's get into the question. I suggest you pause the video, have a go on some scrap paper, then unpause the video and watch the walkthrough. Give an equation to show how chlorine forms an acidic solution in water. So there's a little clue, a little reminder in the name that we need to have a source of hydrogen ions, an acid formed. So if you're kind of like stuttering over what to do here, then hopefully that can remind you. So we're going to get hydrochloric acid, kind of get hydrogen ions and chloride ions. Obviously, in aqueous solution, if there's water about, they're going to disperse and be like hydrogen and chloride ions. And then we're going to get hydrogen chlorate. Also like this. You can write hydrogen chlorate like this, and on the mark scheme they show it like this, and I guess that is kind of saying, well, you got your chlorate ions with the negative and you got your hydrogen ions with the positive, and that's how they come together, so they can kind of write it like that. I prefer writing it like that, but there we go. That's how the mark scheme shows it, the one in the circle there, and that's going to get you a mark. So a couple of things you might miss out, the reversible symbol, but there we go. Let's zing on. Now, give an equation for the reaction between chlorine and cold dilute aqueous sodium hydroxide. Another one of these you just got to know off by heart. So if you don't get this right, just make sure this is a good chance for you to see, hey, I don't know my group 7 chlorine reactions off by heart. I need to get them on a revision card and practice them for a few days until I know them off by heart. All of these things are going to gain you marks. This is from an A-level chemistry exam, so hyper important to know this stuff off by heart. Right. There we go. My God, that took pages to scribble out. So this is also an example of a disproportionation reaction. This is another question you might get. Chlorine, when it's in its elemental form, its oxidation state is 0. Here with sodium +1, chlorine also must be +1 because oxygen's always -2, unless with fluorine. Here sodium is +1, chlorine must be -1. So what we see is that chlorine has both been reduced and oxidized. So there we go. That's a disproportionation reaction. You don't need to highlight that in this question. They just want you to write down the equation. Okay, let's move on. That's the first 2 marks done. 5.3. So this is a slightly more skill-based exercise. So you can be forgiven for getting these wrong, but you really need to beat yourself up if you don't know the equations properly. Okay, if you don't know those off by heart. But things like this is more of a skill-based exercise. So this is something you can work on and develop the skill. In acidic conditions, ClO3 minus ions oxidize Cl minus ions to form chlorine. Deduce a half equation for the oxidation of chloride ions to chlorine. Deduce a half equation for the reduction of ClO3 minus to chlorine. Deduce the overall equation for this reaction. So this is kind of like applying your knowledge. So we know that it's the oxidation of chloride to this. So we know for this half equation, you're going to just start like this. And it's telling us that it's oxidation. What do we know about oxidation? Remember, oil rig, oxidation is loss. So we know this is losing electrons. So on this side, we show the electrons on the right-hand side being lost. They've come off of there. And we just need to balance it now. So we're going to put a 2 there and a 2 there. And that is going to get some marks. So again, it's not that you memorize this off by heart, but the clues are here, and it's a skill-based one. A half equation for the reaction of ClO3 minus to Cl2. So what we want to do, we want to start with ClO3 minus and then arrow chlorine. Now, I really suggest you have a go at this on scrap paper. This is an applied skill-based question, and then you unpause and watch how we work it out. So there's a little bit of skill here. And what I mean by that is you see these oxygens here and you say, okay, what am I going to do with these oxygens over here? Well, in these half equations, when you get oxygen on the left-hand side, you need to replace them, or you need to take them out with water over here. That's how you balance it all up. Now, I've got 3 O's there. Before I start putting a 3 in front of the H2O, I do need to take note that I've got a 2 here. Chlorine's a diatomic molecule. So at the minimum, I need to have a 2 in front of the ClO3 minus to balance the 2 Cls there. What does that do to the number of oxygen? Suddenly, we've got 6 oxygens here, and that means I'm going to need 6 water molecules to balance up those 6 oxygens. Now that means I've got 6 times H2, so I'm going to need 12 hydrogens over here. So now we've got 12 hydrogens over there. And what I need to do is then go, well, look, I've got 0 charge on the right-hand side because I've got chlorine and water. There's no ions over here. So there's 0 overall charge. over here, I've now got 2 times minus and 12 plus. So I've got a total charge between these two bad boys on the reactant side. I've got a total charge of plus 10. So how are we going to get rid of that plus 10 to make sure both sides are electrically balanced? So what I'm going to do, I'm going to put 10 electrons over here as well. I mean, it's best to put them over there by the hydrogens, but I didn't put them there. So as long as it's all written out, 10 electrons plus 2Cl3 minus plus 12H plus. Now that is all electrically balanced because 10 minus and 2 minus cancels out the 12 plus. If you look up here, this is electrically balanced, 2 minus on the left, and we got 2 minus on the right. So you always want to make sure these half equations are electrically balanced. Now what we need to do, we're going to need to put this together to write the overall equation. Again, this is skill based. So how do we do that? Well, we say to ourselves, we're going to combine the two equations, but we look particularly with half equations at the electrons. Okay, so what's going to happen is I've got 10 electrons on the bottom half equation and 2 there. This tells you the ratio. So I need to times everything up here by 5 so that we get the ratios to 1 to 1. And that's what you do with the half equations. So what I'm going to do is I'm going to go 5 times 2Cl minus. That means I'm going to have 10Cl minus. Going to put my little arrow over here. I'm also going to have 5 times Cl2. So we're going to start off with 5 Cl2 because I've had to do 5 times. And I'm going to put 5 times the electrons. So I'm going to put 10 electrons here. We're going to do a bit of cancelling out and addition once we add this down here. So far, hopefully you've all followed that because I had to times this by 5 to match the electrons on the two half equations. I'm writing that down in the overall. Now I just need to copy this down. So I've got plus 2Cl O3 minus. Then I've got plus 12H plus. Now I've also got these 10 electrons that I'm going to put down here. Okay. And on the right-hand side, what do I need to add? I need to add a chlorine. Remember, we got this chlorine. I need to stick that there. So this is going to become a 6 chlorine because we've got the 5 there and the 1 there. So we've now got 6 chlorines coming down. And then I need to add the water, 6H2O. And the only thing I need to do now is go and see, is there anything I can cancel out on either side? And then I just need to check, is it all electrically balanced? And if it is, whoopee-doo. So I've got 10 electrons here and 10 electrons there. So straight away, let's get rid of those. They cancel each other out. 10E on both sides. I don't need the 10E. So what I can do, I'm going to select and bring this over because it's all looking a bit messy. So that's my right-hand side done, 6Cl2, 6H2O. Let's just check this is all balanced. I've got 12H plus, we've got 10Cl minus, so 10 minus, plus 2 times minus there is 12 minus totally, wipes out the 12 plus. It's all electrically balanced. That's the overall equation. So we're smashing out our third mark there. So we get 1 for that and 1 for that. And there we go. Hopefully that showed you how to put that together. But that's a skill-based one. You can forgive yourself when you mess up on those because they're things you need to work on, develop the skills and do loads of exam practice. The memorizing of just basic equations is just standard stuff any A-level student can do. And if you don't know them off by heart, it means you need to put more graft in. So get at it. All right, let's move on. Enough of my waffle. Right, we're coming down here to 5.4, and we've got give the equation for the reaction of solid sodium chloride with concentrated sulfuric acid. State the role of the chloride ions in this reaction, equation, and then we've got the role. So let's get into that. So all we got to do is translate the formulas for these. So we want sodium chloride plus sulfuric acid, H2SO4. This is another one you need to know off by heart. So you should know this off by heart. Now, there are 2 possibilities of products for this equation. So we can form either sodium hydrogen sulfate like this, and I prefer to do this equation, but there is another option. And then we can do HCl. So there we go. So that's the equation I do. Some people like to do, instead of putting HSO4, they put Na2SO4. So you just got your, whatever that is, disodium sulfate. I like sodium hydrogen sulfate because I don't need to do any balancing. If you do Na2SO4, then you're going to need to do some balancing to make sure that you're going to need a 2 next to the HCl and a 2 in front of the NaCl. So yeah, it's not hard, but there we go. That's just the way I like to do it. Now, the next thing is, what is the role of the chloride ions in this reaction? So you might say, well, where are the chloride ions? Well, they're over here, right? We've got, now let's check, is it oxidation or reduction? So what we do is we say, well, chloride, if that is +1, group 1 metal, always +1, then that's -1. We come over here and we say, well, hydrogen's going to be +1 and chloride's -1. So actually, the chloride ions have not been reduced, they've not been oxidized, so they're not an oxidizing or reducing agent. So stay away from saying that. So what is their role? Well, what's happened here? What's it gained? The chloride ions have picked up a hydrogen. What do we call things that pick up hydrogen or accept hydrogen? So this is a base or a woo, hydrogen acceptor, or even better to say proton, hydrogen ion acceptor, not a hydrogen acceptor, a hydrogen ion acceptor, which you might as well say proton acceptor because a hydrogen ion is a proton. And that will get you 2 marks. Lovely bubbly. Right, going to move on. So, all right, 5.5, draw the shape of the Cl3 minus ion, including any lone pairs of electrons that influence the shape. This one I'd say is the hardest question, but it's only worth 1 mark. And yeah. So how do you work this? Well, a chloride ion is going to be your central ion, right? And you think about a chloride ion, and then it's got 2 other chlorine atoms attached. Well, the main chloride ion has, so let's just do bush, bash, bosh. Um, let's get rid of that. Oh my days, what am I doing? So, oh, that was ugly. Right. How many electrons around the central ion? Well, chlorine's in group 7, so it's going to have 7 electrons. So if you think about it, it's got like this, da 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 da. But this little minus sign here is telling us there's an extra electron around the outside of that. So there we go. So 2 of these electrons, this is just me explaining, 2 of these electrons are going to be involved in bonding with these chloride ions, right? So that's going to leave 1, 2, 3, 4, 5, 6. It's going to leave 6 electrons around the central ion, which we've got 3 electron pairs. So I'm just explaining how we get to the fact that there are 3 lone pairs of electrons around this chloride ion. And once you know there's 3 lone pairs, we can do the Bugs Bunny ears. Not sure that you have to put those, but essentially that is those lone pairs of electrons like that. Okay, now you're going to put some brackets around it, and we're going to put a minus there. You don't actually need to show the X's and circles and crosses, so you can get rid of that, and you can just show it like that with the electron clouds instead. Oh my days, my rubber skills are very bad. So like that. So we can just show it like that if we like. Okay, coolio. Let's zing down. 5.6 is the last part of the question. Chlorine forms an ion with the group 3 element thallium. State and explain the bond angle. So it's 2 marks. So they don't say anything about shape here. They say state and explain. So they want the bond angle, 1 mark, and then explanation of the bond angle. So they told us that thallium is in group 3, which means we got 3 electrons in the on the outside of this bad boy. And so, oh, and there's a plus. So we've actually only got 2 electrons on the outside. So what does that mean? If you've only got 2 electrons around the central ion, because it was group 3, but there's a plus sign. So we, instead of 3 electrons, there's only 2. And guess what? Those 2 electrons from the thallium must be bonded to the chlorines, right? And so we're going to have a linear shape. And what's the bond angle on a linear shape? Well, the bond angle is going to be 180 degrees. And why is it 180 degrees? Well, that's the furthest apart the lone pairs can get to minimize repulsion. So that's really all we need to put here. We didn't even need to say the linear shape. So we're going to go bond angle is 180 degrees. And explanation, to minimize repulsion, the bonded pairs move as far away as they can. So this is the furthest they can get away from each other. It minimizes repulsion between the bonded pairs. Okay. And we get that lovely linear shape. Right. I hope you found that useful. Don't forget, share with Kevin, hit the like, punch up the bell, subscribe. Let's get to the marks, people. I'll see you in the next video.
You're still here? It's over.